So let's get into this. Let's talk about HTTP requests and response. So what we'll talk about, I'll give my slides, I'll give my examples and everything. But if you ever want to go to the core, the root source of everything we're talking about, there's the RFC 2616. This is the RFC that defines HTTP version 1.1. Everything that you need to know about HTTP is going to be defined in that document. At least HTTP 1.1, the HTTP that we'll talk about in this class. Everything's defined in this document. There's tons of text. It's a huge document, depending on your standards, I guess. But there's a lot of text here to define every single piece of HTTP. What we'll focus on, at least up front, are sections 4, 5, and 6. The HTTP message. How is a message formatted? How is a request formatted in section 5? In section 6, how is a response formatted? So right now we're really concerned about the communication between a client and a server. When a client sends a request, what's the exact format? What's the format of a request line? What's the format of the body? Well, that's defined in section 4, the general format of an HTTP message. And when we send a response back, what's the format of that status line? What are the different codes? Actually, I think that's defined in a different section. But what are the different codes? You can see all kinds of good information here. The different request types. And all that's defined specifically in this document. So anybody who wants to speak HTTP, if you're developing a browser, if you're developing a web server, or any other mobile app, anything that needs to speak HTTP, this document is what defines what you have to code. It's going to define everything. It's going to define what CRLF means. It's going to define a status line, how to distinguish between the headers and the body, how the headers have to be formatted. We have key, I say key and value, but name and value separated by a colon, each on a separate line with a line feed, carriage return, etc. So all that's defined in this document. If anything is unclear with something that I say, just go to the docs. The docs will have your 100% accurate answer in there. You will find your answers in that document somewhere. So I just want to put that up front. My slides, my lectures, it's to take some of that content, the pertinent pieces for your assignments and for this course, and make them more digestible for you. But if you ever just want to go to the source, hit up this RFC 2616, and that'll be true for all the protocols we talk about. There will be an RFC that clearly defines what the protocol is. That's the starting point of everything, are these RFCs, these requests for comments. And then everybody follows those. If everybody's following those exactly, the internet works. If, say, a browser doesn't implement HTTP exactly, that browser's probably not going to work very well because the web servers are going to implement that exactly. For example, if you do /n instead, actually we'll talk about it in the slides, but so if you do just a /n for a new line, like you've probably done up until now, and like you'll do with everything except HTTP and maybe some other protocols, things are going to break. This is one of the most common errors that I've seen in office hours with request responses and just the browser not getting any response from the server or not being able to parse it, is not having the new lines in the correct format. So an HTTP new line is has to be a carriage return line feed. This is back from the days of typewriters. So when you're typing on a typewriter, you get to the end of the page, you have 2 steps to go to the next line. A carriage return, which is the big block that is actually typing the characters on the paper. You have to move that back to the left. And then you have to do a line feed, which rotates the paper and moves on to the next line. So it's a 2-step process. When in the early days of computers were designed around the real world, the physical world, and what people were used to. So new lines were actually carriage returns and line feeds to simulate what people were used to with a typewriter. And you could actually separate these. You could do a carriage return without a line feed. You could do a line feed without a carriage return. I don't know why you'd want to, but those are possible. So in our code, for our purposes, a carriage return is going to be a /r, and a new line or a line feed is a /n. /n I'm sure you're all used to, but the carriage return is going to be a little new. New lines have to be /r/n. And this is two separate characters. There are two separate characters, /r/n, that have to be there. So if you have just one of them, it's still valid to have just one of the characters. Nothing's going to yell at you, compiler-wise or anything. But if you don't have both of them, you're not speaking HTTP. And depending on how the browser, some browsers will accommodate for a lot of errors. So you might have issues where it works in this browser, but not in this browser if you don't have your /r/n, or most likely it just won't work anywhere. So /r/n, that's a new line character in HTTP. I'm surprised I don't get those two mixed up more often when I'm talking. But in HTTP, this is a new line character. I don't want to see anybody making this mistake. This is a new line character. If I see /n's without /r's in your code, when you're creating an HTTP response, you're wrong, and your code's, that's probably why you're in office hours asking me about it. So this is what a new line is. And when you're parsing requests, when you get an HTTP request from a server, the new lines are going to be /r/n. So for example, if you get a request and you say request.split on /n, you're going to have a lot of /r's hanging out at the end of every line. So that's something you got to be aware of too. I would do, first thing, I get an HTTP request. I'm going to say this request, the string containing my request, dot split on /r/n. That's going to give me all the lines of the request. All right, so let's talk about a request. Think of it as one char reduces error. You can think of it as one char, but when you're coding, you have to be aware that the computer sees that as two separate characters. If you think of it as one character in your visual model of how HTTP works, I ain't gonna stop you. But the computer sees that as two characters. So be aware of that for when that matters. So actually the new lines, those /r/n's, are always going to appear before the body of a request or response. That new line character, the /r/n, does not apply to the body at all. The body can follow any format that it wants. It's not strictly part of HTTP. That's just a blob of bytes as far as HTTP is concerned. So that doesn't apply to the body, and the content length only counts the number of bytes in the body. So we don't have to worry about that in terms of counting the content length. Good question. Which, for those of you who don't know what I'm saying there, don't worry, it's in a couple of slides. We'll talk about content length at length. So here's a simple request is like the simplest request that your server can receive. Technically, we could get rid of the host too. That would be even a simpler request, but I wanted at least one header there to keep you remembering that headers exist. Headers are a thing. So this would be a request. Right here would be is a /r/n. Right here is a /r/n. And actually right here also is a /r/n. Which, come to think of it, I probably should have just added those to the slide directly. So with this request, at this point you should be able to tell me what is being requested here. And if we were live, I would shut down lecture and be like, what's being requested? I could still do that, but let's just keep this moving. So let's break this apart and talk about how this is structured. And first, the first line of every single request is going to be the request line. We're always going to have the request line in this format like we saw on Friday, where we're going to have the type of the request for our purposes, either GET or POST, followed by a space character, followed by the path of the request, including any query strings or fragments, followed by a space. In this case, we're just requesting / the root path, followed by another space, and followed by the HTTP version. which is always going to be HTTP/1.1 in our case. So if you want to just assume that this is HTTP 1.1 without checking it in your server, I'm going to be fine with that. You don't have to say if HTTP/1.1 equals the third value in the request line, then respond, else return 404 wrong protocol, not 404, but whatever error code you would want to send. I don't know what error code you would send. There's probably a specific one for wrong HTTP version or unsupported HTTP version. And then a /r/n. So if you read the request up until the first /r/n, that gives you the first line. Split that on spaces, and then read the request type and the path. And that's going to determine how you're going to respond to this request. And there's a few things that you can do. Maybe I'm getting a little ahead of ourselves here, but there's a few things you can do. At least to start, I'd say most students for homework 1 at least, you'll get away with saying if request type equals get and request path equals /hello, then run this code and serve this response. Else if request type equals get, request path equals /hi or hey, I forget what I put in the document, then respond with this code. But I do recommend, at least at some point in the further ahead you can do this, the earlier you can do this, the better, is write some more generic code to be able to avoid this massive if-else statement that you'll have by the end of the semester. So if you want to pull out some regex, if you're comfortable with regular expressions, or if you want to use functional programming, which I would recommend, have your function for each response in a separate file, or at least grouped together in a meaningful way, and then say if the path matches this, then call this function over here, or some way to organize it. I mean, it's up to you what the cleanest way that you like is, but I would have some way to do that. And then to be able to add functions to your, maybe I'm explaining that poorly, but have a method to add functions based on path. So have an add path, the string for the path, the HTTP request type, and then the function that you're actually going to execute based on that. So you don't have to have that big if-else block. I feel like I didn't explain that well, so maybe I'll have to give an example when I have time. Probably not today, though. The request line, this path, is going to be important to be able to read, to figure out how you're going to respond to the request. Usually if we request, or put all the code in main, please don't. I mean, you can put all the code in main, but you're going to have a very difficult time when you get to the later homework assignments. The more organized, the better software engineering practices and architecture practices you follow, the better time you're going to have, especially on the later assignments. Usually if the request is for /, this is the root path. This is somebody wants to visit your site and they just want your main page or your home page or whatever. By convention, servers usually look for index.html. If you've done web development before, you've created an index.html. That's because that's by default the HTML file that web servers will look for when the path / is requested, the root path. The server is coded. I think this started with Apache. I think this is the convention they started and then just carried over throughout the web. Now, I could be wrong on that. Maybe there was a predecessor to Apache. But it will look for index.html and then serve that HTML file at the root path. Just by convention. There's no magic there. It's just people agreed, let's just call it index.html. When somebody requests the root path, we'll look for this file. If it exists, serve it. The path can be different, and depending on the path, you'll want to serve different responses. And then the headers, these are going to be separated by a colon. We just looked at the documentation. I just updated this slide too. We just looked at the documentation where I had it as colon, but I added the space. We just saw the documentation that says they are separated by just a colon, not a colon space. From every request that I've ever seen, there's always a space there. So take that for what it's worth. In my code, in my solution for the homework assignments, I actually split on colon, only colon, And then on the value, I call .trim to remove all leading and trailing white space. So I'd recommend doing something like that, just so no matter what, you're going to be covered. Unless white space matters in those cases, for those headers, you'd have to treat them a little differently. White space won't matter in any headers in this course, so for what that's worth too. So the headers. We actually don't have to parse headers for homework 1, but we will do a lot of header parsing starting with homework 2. Do we? I have to think about that. Do we parse headers in homework 2 even? We should be, but I don't know if we do. Yeah, I'd recommend Postman. That's something, to be honest, I haven't gotten into Postman. Like, I've used it a little bit. I should be using it more. I usually just use the debugger right in the browser. But for debugging post requests, Postman is great. So the response is going to be structured similarly. When you get a request, you're going to respond with a response and send it over the TCP socket. And your response has to look like this. It has to be in this format, at least at a bare minimum. This is a minimum response to be able to respond to a client's request. So let's break this one apart and talk about what you have to write. So, and just to recap, for the request for this homework, you're looking at this request line is the big piece of information. What's the request type? For this homework, it'll always be GET, but I recommend thinking ahead and always checking if GET and path. Check both of those pieces of information and then serve the response. Because when you start serving post requests, you don't want to have to go back to your homework 1 code and update it all to say if GET, if GET, if GET. You want to be able to move right along without revisiting your old homework stuff. So that's the request parsing that you have to do. Find the first line, split on spaces, check the important values. For a response, the first thing you're going to send is the status line. What's the status of this response? What happened while this was being processed? And this is going to be 3 values, just like the request line, but the values are a little bit different order. So first is the HTTP version. Again, always HTTP/1.1 in this course. So you should always have HTTP/1.1 and then a space. That's always going to be the start of your response. That's always the very first start thing that your response sends. Is HTTP/1.1 space. And then the next value after that space is the status code, which is a code that says, gives general information about this response, and then a space, and then a human readable status message. And for what it's worth, I feel like I'm using that phrase a lot here, but for what it's worth, the status message can contain additional spaces. So the browser is going to look for the first 2 spaces to separate the values, and then whatever's left is going to be the status message. So in this case, we're sending back a 200 OK, which means everything went fine. Here's the information that you requested. We have 2, assuming that our response has a body, which in most cases it will. We'll see one response that won't have a body, our 301, for this first assignment. But for all other purposes, our response must have at least these 2 headers, content type and content length. The content type tells the browser what type of information is stored in the body. In this case, we're going to send plain text, so it's text/plain is going to be the content type. We will talk about a lot of different content types as we get into homework 2, where we're going to serve HTML, we're going to serve CSS, we're going to serve images, we're going to serve JavaScript. Those will all be different content types. For our purposes now, we're going to send plain text as our content type, which will just be displayed as text in the browser. It won't be rendered as HTML or any of that. And also the content length. This is something we'll talk about a lot, especially on homework 2. Content length will be critically important. Content length is the number of bytes in the body. Content length is the number of bytes contained in the body. So here we're sending plain text. We're sending the word hello. Each character in the word hello happens to be an ASCII character, which means each character is going to be a single byte. So for our purposes here, content length is going to be identical to the length of the string in the response. Now, if we're sending non-ASCII characters, which we won't for homework 1, but just a foreshadow here. If we're sending non-ASCII characters, so if we're sending something that's in UTF-8 but not in ASCII, then the number of bytes to represent a character is not going to be equal to 1 in all cases. So in those cases, our content length will not be equal to the length of the string. So if you're doing string.length to generate your content type, you're wrong, and you're going to lose points on homework 2. So we'll get to that. There's so much stuff in this course. Like, I always want to, I'm finding I have a problem now that I'm teaching this course a couple of times. I'm always thinking ahead and trying to tell you the cool stuff that's coming up without, laying the foundation first. So forgive me for a little bit when I go ahead, when I try jumping ahead like that. We just got to talk about the format of a response right now, request and response. So we have at least these 2 headers. You can have more headers. You could set cookies through headers. And then after saying that, I do it right there. We'll talk about cookies later. But we need these 2 at a minimum if we have any body in the response. What's the type of the bytes in the body, and how many bytes total are there? Yes, 404 also has these 2 headers. So when you get and just very quickly, because that is something we'll talk about today, when you get a 404, like as a user, you're navigating the web with your browser and you get a 404. When you get a 404, you're actually looking at some content. The content is the 404 page. So we're serving that 404 page when somebody gets a 404 on our server. So we do have some information that we're sending them, the 404 page itself. So we do have to have content type and content length. All right, so the headers, each line here is separated by a /r/n, and the body and the headers are separated by a /r/n. So right after the last header, there's going to be a /r/n/r/n. This is going to be a very important substring throughout this course. It's going to signify the end of the body of a request. So when we want to tease apart the headers and the body, or in this case, when we're writing a response, we have to separate them by a /r/n. Now, the first /r/n, or CRLF, I'm going to say CRLF because it rolls off the tongue better. The first CRLF is going to be, hey, right here, to say, hey, this is the end of this specific header value, key value. And then the next line, this is, on Friday I said there will be a blank line. What that means is there's going to be a new line, and then immediately another CRLF. Immediately another CRLF. So effectively we have CRLF, and then the start of the response. So we have to have that specific substring, CRLF. That is how we know the body, the headers are over and the body starts. It's very important to be able to get these apart, because the headers, we're going to have code that reads line by line, looks for a colon, splits the name and the value for each one of these headers. But we have to know when we're done with that, because if we get to this line and we're still saying look for a colon and split on colons, and we're going to crash. If we're on this line even, we're looking for a colon, split on colon, get the second value, because get the value index 1 because that's the value I'm looking for. Index out of bounds error, you're going to crash if you're not looking for this specific character. That specific, I say substring, but subsequence of bytes is more accurate. These response codes, we talked about a few of them. I'm sure you were familiar with quite a few of them before you even entered this course. But one thing I want to mention about these is the level of code, signified by the first digit in the number. If you get a 200 error, if you get a 200 response, which is 200, 201, anything that starts with a 2, this means everything went well, and here's some more information. You might have a different 200 that says not just okay, but I can't even, I've never even used a different 200 code. Everything went great. Everything went super great. I don't know. I don't know what the other 200 codes are. I think there's only 2 or 3 of them. Now I don't remember off the top of my head what they are. 200 OK is the most common one to use. Out of all the error codes, out of all the codes, not just the 200 level. 300 level means you have a redirect. So that means the user requested something, and we want to say, hey, go request something else. We're not serving anything at this path. Go request another path. Here's the path that you should request. And there are different types of redirects. Up to date, if you have caching, if somebody says, hey, give me this information, this is the last time I requested it, the server can respond with a 300 level code that says, hey, that hasn't been updated since the last time you requested it, just use the one you already have. We can also have a redirect. Hey, we don't maintain this path anymore. Here's the path that you should request. And other things that we can do with 300s, but just means redirect the user. 400 means there's an error that was caused by the client. This is your forbidden, your not found. The client did something, they requested something that just no, we're not letting the client access that, or it doesn't exist, or something else that the client did wrong. And 500 level, the scariest ones, this is something that the server did wrong. I can't serve your request. You did everything fine, client, but the server messed up, and the developers were going to sound the alarm, and they're going to work on this error because they got some work to do. Does the CRLF go after the space, or does it go right after the first? It goes right after the first // So there's a CRLF and a CRLF here. The reason it's on the next line is just because it hits the /n is the reason I'm putting it down here. But really thinking of this as a sequence of bytes, we could have this, then a /r/n, then content type plain text plain, CRLF content length 5, CRLF hello. It's really all on one line. It's only displayed on separate lines visually for us humans when those /n's are read. So there's no space between. It's /r/n/r/n. Those 4 characters will appear as a substring or a subsequence of bytes in the request and responses that have in all requests and responses. If there's no body, the request will end with that. That sequence will end with 2 CRLFs. So even if there's no body, there will still be this blank line here, which helps us parse. It helps us know when the end of the request is, if there is no body. So let's talk about a few different response types, codes. First, 404. We have 3 different response types that we have to send in the homework. A 200, which we've talked about the details of that, the 200. The 404, which is objective 4. Yes, I realize I'm doing these out of order a bit. I did that on purpose, a little bit, but I did it on purpose, but I realize that some ways of looking at it might not make sense. I could explain why I did that, but it's not important. And then the objective 3, the 301, that we'll talk about in the next few slides. So 404, let's talk about how to do this. The response is really identical to a 200 response, except the code is different. You get the 404 not found instead of a 200. Other than that, it's identical. You still have to have the content type, content length, and the response that's going to be displayed to the user, but you hit the 404 not found instead of a 200 OK. It's really the only difference. And that's why I talk about this one first, because it's the same as what we just talked about. Can you change it to like 200 good? We'll be looking when we grade. We'll be looking for the OK. Outside of this course, outside of that, there's nothing stopping you from doing that, except convention. So it's convention to do 200 OK and follow the code names that exist, but nothing is going to crash. The browser will display good just the same. Like for some sites, I was doing some testing on the not found. Some sites will do not found all in caps. Some will do it with this case, capitalizing the words. You could do it with all lowercase. Like the exact string doesn't matter. That's just a human readable description. The computer is not going to the browsers, the clients, they're not going to read this string with any meaning. They're just going to forward that to the humans. But it will read this error code. The code has to be the same because that's what the computers are going to read. And that's what the client code that those developers wrote is going to read, because that has more meaning to them. And when you're formulating your response, same as an OK, same idea. A 301, this one is a little different, which is why I talk about it last. For a 301, there's actually no body to the response. You're going to give the 301, and then there has to be a location header. This is a required header when you send a 301. This is saying, hey, this has moved. We don't serve anything at this path anymore, or ever in some cases. Like for your homework, you're never going to send anything at that path. You're going to always give a 301. And here's the location where we've moved that content to. So here's a 301, redirect to this new location. So somebody makes a request for a specific path, and you want to move them. Hey, I don't serve anything here. Let's redirect you over to this other path. Instead of maintaining that in your server and just serving the content, it's helpful to serve them. Just say, you know what, make another request. Go to our new path. When a 301 is returned, the client makes a request, gets our 301 in response. When they read this location in the 301 response, they're going to make a second HTTP request for the new path. So there's going to be a brand new request to your server. Your server won't even know that that request was made after a redirect. There's no way of knowing that, hey, this is a redirect request. I shouldn't say no way. You could probably parse out the other headers. Browsers give us a lot of information to work with. Refer, I think it's called. You could probably read that. But really, there's no good way to say, hey, this is a 301. You're just going to get another HTTP request from the same client. And no, there are no content headers here because there's no content to send. When you get a 301, as a user, you get a 301, you're never displayed any information. Whenever sending any information with the 301 except this one header, and then your browser automatically makes a request to the redirected path. And then whatever the redirected path sends back, assuming it's not another redirect, that's going to be the actual content that you're served. So nobody actually sees the 300. Browsing the web, you've never seen a site give you a 300 level response because your browser automatically follows the redirect and just goes there. So there's no content to display to the end user. So no content headers. Does the server need to know which path send the GET request? Yeah, yes. So this would be like in your homework for objective 3, you would say you get a request, you're going to check, okay, this is a GET request for this path, and I'm forgetting, I think it's hi or hey. If that's the path, then you're going to respond with this 301 response. So you do need to know what path was requested, because some paths you're going to serve content, some paths you're going to serve 301s, and all other paths you're going to send 404s. Say, hey, that doesn't exist. So you're checking the path of the request and then responding with a different response based on that path. Yeah, the space and not found. So the browser is only going to read the first two spaces in a response in the status line. And all other spaces, there can be spaces in the human readable response code. And the browser is just going to look for these first two, and then the rest just goes. That's different from the request lines that we have to parse. The ones we have to parse are always going to contain 2 spaces. So that makes it a little easier for us. But the browser does have to do a little bit more. The browser can't do .split on string. It has to look for the first one, look for the second one, do index of, or however they want to do it. Probably regex. And probably optimize to hell for that. All right, so and this path can be a relative path. So for example, if we only give this /new path without giving a full URL, the redirected request is going to follow the same protocol, host, and port as the original request. So if we just say /new path without giving a full URL, it's just going to make it to the same server. We're going to get, our same process actually is going to get that next request. So if somebody makes a request for old path and we respond with this 301 with /new path, we're about to get a request from that same browser for to the same server of /new path. We don't have to do this. We can also redirect to a completely different protocol, completely different host, and a completely different port if we want. We just give a full URL as the location. So if our location is HTTPS Google, then the user is going to be redirected to a completely different site. So if we want to say, hey, we moved that, maybe you have an old domain name running an old server, say, hey, we moved, we actually have this new server, this new domain name over here, that's what you should request. You can send them to a whole nother server with a redirect. We'll do relative redirects for homework 1. And new line reminder, in case I haven't said this enough, new lines in HTTP are a /n and a /r/n, not just a /n. So let's take a look at an example. Oops, I'm on the wrong window. So let's take a look at an example. Let's pull our server up, and I want to add a little bit to this server. And I want to point out a few things that we need to talk about here in the last 10 minutes. So let's open our server. When you, I want my, yeah, okay. So a few things. TCP sockets only send bytes, not strings, not characters, bytes. So this is going to be different for each language, for whatever language you're using. But if you're using Python, when I receive the information, I'm going to get that information in bytes. This is going to be a byte array. And if I want to convert that to a string in Python, it's .decode. You may have seen these in other contexts before. In our context, we really have to pay attention to this and focus on what this is doing, especially when we get to homework 2 and beyond. So this is a byte array that I receive, just an array of bytes, ones and zeros in chunks of 8 coming over this stream, this socket stream. I decode it, which is going to turn it into a string. And in Python, the default encoding is UTF-8. So when I do .decode, this actually takes an encoding. I could do, I forget the exact format of the string. I think it's capital UTF-8. I could do this and specify the encoding. By default, Python's going to follow UTF-8, which is what we'll use for our purposes in most cases. So if I just do .decode, this is going to convert that to a string that I can then print to the screen. Actually, let me add another print statement here. I always spell received wrong. I gotta be careful there. Received data. So let me print received data and also print received data.decode. Do I have to str? I don't think I do here. And then I'm going to respond using a Python socket server. Self.request.sendAll is going to send a response. I'm not doing any parsing of the headers. I don't want to give away too much of the solution, especially since it's unfair to people using Python. But when I send a response, I'm going to send my response, my status line, and we're just going to send an OK, /r/n, content length, number of bytes. I don't even have content type here. The content type, I'm sending plain text. Content length, I'm going to put as 5 bytes. 5 bytes. And I'm going to specify that this is the end of the headers and the body is going to start. And then I'm going to send the body of my response. I'm going to say, "What's up, world?" with a couple exclamation points. And then, since this is a string, and we can only send bytes, just like we can only receive bytes, we can only send bytes over a TCP socket. TCP only speaks bytes. I'm going to have to encode this. So this is going to take my UTF-8 string and encode it as a byte array, because send all needs a byte array. Send all doesn't know what to do with strings. So we had to decode when we receive data and encode when we send data. So we can work with strings in our server, but we're only sending and receiving bytes over the TCP socket. Oh my goodness. I went 1 pixel too far and it messes up everything. There we go. And you can see the output there. I'll run it just in good faith. I'll run my server. Actually, I want to see the print lines too. And we get our response displayed as plain text in the browser. So if I go to network, let's resize this again. Yeah, got refresh, localhost, and we can see this response that we got. We can see the exact response headers. This is exactly what we sent, and the browser is able to parse this because we followed the HTTP protocol just fine. We followed it, the browser's following it, we can communicate effectively. And then the body of the response, what explanation or what apostrophe. And if we look at our server, we can see a lot of the response, or a lot of the request data. The first thing that we get, that we print in our server, is the request as a byte string. This B and then single quote. It's going to tell us that we're printing a byte string, and then it's going to print out the bytes of the request. Now, between Python, I forget exactly who does this, but between Python and the terminal, it's going to auto-convert some of those bytes to ASCII strings. So instead of printing out the hex for each of these, it will auto-convert some of them to ASCII for human use, for us to view. The machine is seeing just ones and zeros. So we do get some information here, but you can see it's not going to treat the new line characters as new lines. Like here, I convert it to a string, I decode it, and then print it again. It's going to print it in a more human-readable way because it's a string now instead of a byte array. But if you want to see the actual bytes coming in, the /r/ends, we can see that this should end in a /r/n, to be honest. I'm going to table that one because that should be ending in a /r/n. Unless I'm mistaken, I'll keep you posted on that. And we can see all that information. We can see that the new lines are /r/ends, and then the human readable version of that. It's before the cookie. Well, we have it separating each header, but after the last header, there should be a CRLF. How would you know? Unless the socket is? No, the socket shouldn't be removing that. I have to think about that. Maybe it doesn't. Maybe I am mistaken on that. I'll keep you posted on that. And then the human readable. So the browser gives us quite a few headers to give us a lot of information. If you're concerned about privacy, one of those pieces of information is your user agent, which gives quite a bit of information about the machine and the software that you're using. Through this string, people know that that I'm on a Windows 64 machine, the version of Windows. They know what browser I'm using, which is encoded in this really silly way because every browser pretends to be every other browser, so they can't they get the content that they want. But they can tell that I'm using Opera from this string, from the Opera string here, but it does pretend to be Chrome and Safari. and an Apple WebKit and a Mozilla. Every browser masquerades as other browsers. Strange stuff. There's a lot of history between user agent and why that is the case. So if you ever go to like download something, by the way, this is a side topic, but if you ever go to download something and it automatically gives you the page to download for your specific operating system, it's because they read your user string, figured out your operating system, and then said, oh yeah, you want the Windows version of this. It's not because you have the most popular or the best operating system. It's because they read your user agent, because you're leaking quite a bit of information about you through that string. And then we responded with, did I print out the response? I guess not. And then we send the response. So, one important thing here. I'm just going to remove this string entirely. Is that our content length did not match the actual length of our content. The browser will take this content length seriously. That's how it's parsing. The body of your request. So I said content length 5 bytes. So guess what the browser did? Okay, I don't know can you see that? Guess what the browser did? It read 5 bytes. Because that's what I told it to do. Read 5 bytes and you're good. So it read 5 bytes and called it good. So this content length has to actually match the length of my content. So let's change that, rerun the server, refresh the page, and then we should actually get our entire message. Now we get the message because we have the appropriate content length. So if we mess up the content length, then we're not going to get all our information sent to the server, especially if we're using encodings. I know I said this Friday, but it's worth repeating. Especially when and I'll repeat it again next week actually, when we're sending an image or any multimedia content that has a specific encoding, a specific compression algorithm, if you're missing one single byte, that compression algorithm might not be able to be decompressed. And your entire image might break, or your entire video might break, just because you're missing a single byte of information. Just because your content length was off by 1, and the browser didn't download all of your content. Not something you want to happen.